Right now we're going to talk about density and water displacement, how to measure and calculate density, and how to use water displacement to find your volume to use in a calculation of density. First, we have density. That's just how compact something is. It's labeled as grams per centimeters cubed or grams per milliliter. Centimeters cubed is the same as milliliters in values. It will not change even if an object is cut in half. That is something you do want to remember. Density is a comparison of the mass and volume. So if you cut the mass in half, your volume is also cut in half. If you cut your volume in half, your mass would also be cut in half because it's equal throughout the entire object. A good way to remember density equation is density equals mass divided by volume. It's your broken heart equation. So again, D equals M over V. The M over V kind of looks like a broken heart because you have the line between it. Or you can remember this diamond here, DMV. So then whenever you're solving one or the other, you don't have to rearrange it algebraically, if that makes sense. So if I was solving for density, I would do my mass divided by my volume. If I was solving for volume, I would do mass divided by density. If I was solving for mass, I would do density times volume. So this line here, my horizontal line, means divide. The up and down, my vertical line, means multiply. So I always just circle what I'm solving for and plug in the other two and then know if I divide if they're on top of each other and multiply if they are next to each other. When you're finding the density of solid objects, you can use water displacement to find the volume. This was actually discovered by Archimedes. He actually discovered this when he was getting into his bathtub and saw the water level rise. And when he realized that this done it, he realized his discovery of water displacement and how he could find the volume of something that was an odd-shaped object without having to do a whole bunch of crazy calculations. Or, scientists sometimes are just lazy, so we don't really want to measure out and use a ruler and calculate things. We can just see how much the water level rises. Anyway, Archimedes discovered this, got into his bathtub, was so excited that he jumped up and ran around the town yelling Eureka, but was running around naked, forgot that he didn't have clothes on. He was that excited about his new discovery. So what we do is we use water displacement to find the volume of odd-shaped objects, or in some cases, just because we don't want to have to measure things out with a ruler. You can find the volume, then you use the volume to find the density of the object, as long as you know its mass. So as long as we weigh out this key first and then drop it in the water, we're looking for how much the water level rises. So if I start at a certain given point, then I drop my object in. Obviously, I don't want any water to splash out when I do so, so you have to do so carefully and maybe slide it in a specific way so that it doesn't splash water out. Then when I see how much it goes up, I record what it goes up by, and that difference between my final volume and my initial volume, that distance in between here, that's how much volume this object takes up. So that's how much water it displaces. So water displacement, this difference between the two, tells me the volume of this solid object. Obviously, there's some things you do want to know when it doesn't work. It doesn't work if the object is soluble in water, which just means if it dissolves in water. If the object floats on top, like if you used a marshmallow, it wouldn't go down into the water. It wouldn't cause the water level to rise, so it doesn't really work then. Or if there's not enough water to cover the object, if I only filled it up to this spot here and then dropped the key in, I would only find the volume in this bottom part of the key, and this top part of the key would not be included because it's not completely covered by water. Or if you filled it up way too high, and then after you put the object in, it overflowed over the top, you actually wouldn't be able to get a good reading because you can no longer read a value. There's no other measurements above here, or some of the water flows out. You can't get a reading, so the density and water displacement don't work. Go ahead and practice a couple of calculations with density and practice some water displacement activities to make sure you understand these.